Hello, so today we are doing a experiment on the tensile tester to kind of try and figure out how repeatably you need to put the specimens into these jaws to get accurate results. And so there weren't a lot of instructions online about that part. So what I did is I made it's batch 1 is what I'm calling it, on Enterprise 2 with PLA Basic a few days ago. And I just printed 10 of these dog bones with the same geometry, all on the same printer. And I'm not going to measure each one of them individually for this. I'm just going to assume that they are all similar enough in geometry to start seeing trends. And we're just going to try it out and see what happens. And if all the results are wildly different, maybe we'll become a little bit more detail-oriented with the test. But this one is sort of just gauging how much the placement of these guys matters in the jaws. And one thing I have seen online is that, let me see if I can open these jaws a little bit. So you can create a jig to make sure that this specimen is placed straight up and down, and any amount of angle at all is going to introduce a bending moment. And in strengths and materials class, I just learned that a 1% change in the angle can actually create like a crazy difference in the amount of stress that this experiences. So this first test is kind of just going to be to see how well can I do this by eye, and then next time I'm going to try to come up with a jig that will make sure that this is vertical no matter how I place it into the vise or the jaws, and see if that makes a difference. Okay, so we've got Blue Hill Elements open, and I'm gonna go to test. And here we can create a new method, run a quick test, and here are some existing methods. And methods are basically just tests that have already been set up. So I'll just go ahead and go through this one that I made. It's called image test. And before it'll even let us go in here, we need to make sure that the Intron is set up correctly, because once we open this, it's gonna basically we're gonna have this machine like live and ready to go. So I'm just gonna go over here, and we're just looking at these yellow E-stops. So this one doesn't move down here. There's one here and here. I don't know why I said E-stops. I meant limit switches or limit like stops, or however you want to call them. But we know that we're going to put a specimen here, and it's going to be in tension, and it's probably going to displace by like 4 millimeters or something. But we don't really want this guy to be able to go like all the way up there, and I also don't want to cut him off early either. Like I don't want to have this hit this switch before we reach our max displacement, because that will just end the test. So I'm just going to put it somewhere like right here, and we know that this jaw is not getting any closer. The specimen is not going to be in compression for this test. We're doing a tensile test, so I'm just going to leave this one right here. And that's what that's saying. So I'm going to press OK. And now here is our test kind of like UI. So this is what we're going to be looking at when we are looking at our results. And here we can set the thickness and the width of our specimen, which I believe are at the correct dimensions, but I will double check that before we start. And here in the method, we've got general. We've got a bunch of settings. We've got general, sample, specimen, measurements, calculations, test control, console, workspace. And there's a live stream that goes through these way better than I can. I'm just gonna go really fast, just give it like a really broad overview. So we've sample is the first thing, and I have just made like a sample description that says MH first test sample. And we can add samples. So there's gonna be 10 samples in this batch, because that's how many things I printed, right? And like, so yeah, so the whole thing is called a batch, and then like each individual dog bone is a sample. So there's some available options here. The specimen, this was just inputting what our specimen looks like. So we chose rectangular, and then The kind of the part of the specimen that we care about, the geometry that we're looking at, is the thinner part, because that's the part that's going to break. The thick part is just so we can hold the specimen in the jaws. So that's just what all of that is describing. And I've got some measurements. We are measuring, we can measure a bunch of things, but we are interested in force and displacement. So those are the two things that we're going to be looking at because we're making a force displacement graph. So over here in calculations, we are looking at like the two things that we're interested in on our force displacement graph is the where the specimen breaks and then the maximum force that the specimen experiences. But you can do all sorts of other things, especially with like an extensiometer. I think I said that right. You can get like a real stress strain curve, and we're going to do that eventually. And then we've got test control. We start the test by hitting the start button. We've got a pre-test sort of setting. So we're saying that before the test starts, we want to preload our sample to 10 newtons. And that's just to make sure that all the samples start off with like the same amount of tension on them, because when you put samples in, some of them can be in more tension than others. But we are just looking at all of them. And where was I? Okay, yeah, so we are preloading all of our specimens so they start at the same tension, and that's just going to make everything a little more consistent. If I go over here to test, we are saying that we are looking at displacement, and we are moving our jaws at a rate of 10 millimeters per minute, which is pretty slow, but we don't want to go fast because we're not that experienced with this machine. And then our end of test criteria is we've got two things. So our machine is rated for 5 kilonewtons, and so basically we don't want to tell the software to try to pull more than 5 kilonewtons because it will let us do that, and that will damage the frame. So we've got end of test criteria 2. This just means that if this scenario happens, it'll just automatically end the test. If we reach a force of 4 kilonewtons before the specimen fails, then we are automatically ending the test. But we'd also want to end the test if the specimen broke. So it also makes sense to say that when the specimen breaks in the test, and that's not exactly what this is saying here. This is actually saying if the measurement, if the rate of change of the force drops by more than 40% suddenly, like over a small period of time. I'm not exactly sure how small of a period of time that is, but basically if we experience a sudden drop of force, that indicates that the dog bone probably broke in the middle, because all of a sudden our jaws are going to be working a lot less hard to pull it apart. And so we're saying if we experience a sudden drop of force, we're also going to end the test. So that's our end of test criteria. And I don't think I did anything with data. Okay. So that here we've got our live displays. We're looking at force and displacement, units of millimeters. The workspace stuff is kind of just like some, I think GUI things, like if you wanted to set up a bunch of samples to be taken the same way and have like your techs doing it a certain way, you could mess with the workspace. Exports is for if you wanted to look at exported data and like import it into like a spreadsheet or something, if you wanted like the raw data. And then I don't actually know what workflow does. So that's kind of what we're working with, and here is what we're going to see on this graph. Is going to start populating as soon as we run a test. Okay, so here is my dog bone that I loaded into the jaws, and since I don't have a jig to make sure that it stays exactly vertical, what I've done is I've tried to line it up on this front side of the jaws on both sides, and hopefully that will make it pretty vertical. And anyway, I already ran a test, so this is what our first specimen's results look like on the graph. And I'm just gonna go back over here and do it again. So we're in setup mode, and we have to press unlock before it will let us run a test. But as you can see, we've got our displacement set to 0, and our force is low. We could look into calibrating that a little better for next time, but we're just gonna see what happens for now. And I'm gonna press go. And if I just press go without pressing unlock, it'll give you a little warning. And if I press unlock and then go, now our test has started. So we can see that we're getting like live feedback. You might not be able to see it on video, but it is stretching out very slowly. It's gonna break in any second now. Oh, there it is. And as you can see, as soon as it broke, the software detected that force drop and it ended the test. Okay, so I'm just gonna go ahead and loosen the jaws, grab this sample out of here. And this one, it didn't even come all the way apart, but it almost did. Interesting. And then one thing, we can see how much displacement we got, which was 4.184 millimeters. And if we go over here and we press, I'm gonna zoom out a little bit so it's easier to show. If I press unlock and then the back button, our jaws are gonna return to 0, a displacement of 0, which is kind of cool. So I believe that is important for the repeatability of the tests. So we're just gonna do that. But yeah, I'm just gonna do the rest of the test just like this and come back with a graph with 10 specimens on it. Okay, so here are all of the final results, and it's split into 3 graphs for some reason. I'm not entirely sure if that's because of a setting that I made or because of only being able to like really see 4 lines on one graph. But anyway, it's kind of interesting. Their maximum force was very close. There's a standard deviation of 0.01 for max force. Everything was about 1.18 kilonewtons. And then, but our displacement at break was pretty variable. So in here you can kind of see it was between like 4.5 and 5.5 roughly. And if I go over to some other graphs, one of the specimens was weird. It kind of just broke slowly, like you would expect TPU to break, so it kind of broke our standard deviation a little bit. I guess you would call it an outlier, because it broke at, I think, let's see if we can find it. I think it was, oh yeah, 6.57 millimeters right there. If we go to our last couple tests, we've got, those were kind of within our normal range, between like 4.5 and 5.5-ish. But actually no, this one broke at before 4. So that one was another outlier at 3.87. But yeah, so kind of interesting. It'd be fun to dig into these results. You can print a report whenever you are done and you want just to have all your graphs and all your data available. So that's what I'm gonna go do now.